temperature of 70 Celsius. Now when you collect a gas over water, so here's my sink, here's my flask. When you collect a gas over water, you don't just have your gas in there, you also have water vapor. So when they say the pressure is 122 kPa, that's not the pressure, that's the total pressure in there. We have to subtract out, Nick, the water vapor pressure. That's why you go to Appendix O. Our T1's 27 degrees Celsius. So you go to Appendix O, and at 27 degrees Celsius, the pressure is 3.6. So we have to subtract out 3.6 to get our P1. So now we've got V1, T1, P1. We've got P2, we've got T2. We're trying to find V2. We will use the combined gas law. Multiply both sides by T2 over P2. That cancels. So we're left with this. Okay. Now we can plug in our numbers. If I went too fast, what you can do, Agnieszka, is just watch this over and over again on YouTube. You can slow it down. So T2. Oh, it's got to be in Kelvin, right? So we got to add 273. So that would be 343 in Kelvin. So 343 times P1 times V1 divided by P2. P2 is the 107 kPa. T1, I have to add the 273.
Hard voltage heat.
That's 300 Kelvin. So 343. Final answer is, really I should have 3 sig figs, not 4. So the final answer is 102 kPa. And yeah, that's a little tricky one. It's a lot of work there. The last problem is the same thing, just different gas law. And go to number 12. We're collecting 372 milliliters of gas. Our T1 is 90 degrees Celsius. Our P1 is 111. We're going to standard pressure, which is 101.325. So you needed to know what standard pressure was. We're starting at this pressure, we're going to P2, and then we're going to find V2. we're collecting over water. So just like in the last problem, we have to subtract out the water vapor pressure. So Shustov, we have to go to Appendix O. And at 90 degrees Celsius, the vapor pressure is 70.1. Okay, so at 90 degrees Celsius, the vapor pressure is 70.1. So we have to subtract that to get our real P1. And then we're set to go. Temperature is staying constant there, Connor, so we don't have to worry about it. P1, V1, P2, V2. Solve for V2. Plug in the numbers. So P2 is, P1 is 40.9 times V1 divided by P2. And the V2 is 150 kPa. Yep,
It's a volume, not gonna be kPa.
can't be. Gotta be,
I did the same thing on problem 11 too.
I did?
Yeah. And so,
We broke 1,000! Can't have kPa.
You need those horns.
Milliliters.
centimeters cubed.
Oh,
Fucking
centimeters
school
cubed. That one should be milliliters. So we put those mistakes in here. That puts us at 100, 1,000.
Like right at 1,000.
And then, if I made a mistake in your test, let me know, I'll fix it. Otherwise, we've come to the end of another episode of the Chemistry Corner. So now we can sing our ending song.
Thank God.
Good night, sweetheart. Well, it's time to go. Boom, 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 boom. There we go.